No serializer found for class org.hibernate.proxy.pojo.bytebuddy.byteBuddyInterceptor Introduction. A common error in Spring Boot applications using JPA/Hibernate is no serializer found for class org.hibernate.proxy.pojo.bytebuddy.bytebuddyInterceptor. This error usually happens when returning JPA entities directly from a REST API, serializing lazy-loaded relationships, converting Hibernate proxy objects to JSON using @one-to-many, @many-to-one, or @one-to-one relationships. It can be confusing because the entity itself looks fine, but JSON conversion fails. Spring Boot usually uses JSON to convert Java objects into JSON, and Hibernate sometimes creates proxy objects internally for lazy loading. That is where this problem begins. What does this error mean? It means JSON is trying to convert an object to JSON, but instead of seeing a normal entity object, it encounters a Hibernate proxy object. In simple terms, entity contains Hibernate proxy, means JSON tries to serialize it, means serialization fails. Example concept. Entity returned means lazy proxy present, means JSON cannot serialize proxy class. Why this happens? Hibernate often uses proxy objects for lazy loading. For example, if an entity has a relationship marked as lazy, many-to-one, fetch equals, fetch type lazy, private department. Hibernate may not load the full department object immediately. Instead, it creates a proxy object such as org.hibernate, proxy, pojo, ByteBuddy, ByteBuddyInterceptor. When Spring Boot returns the entity as JSON, JSON tries to serialize that proxy object and fails. Example concept. Lazy relation means Hibernate proxy created, means JSON serializer does not understand proxy. Suppose you have @entity, public class, employee, ID, private long ID, private string name, @many-to-one, fetch equals fetch type lazy, and controller. Get mapping /employee with ID, public employee get employee, path variable long ID, return employee repository.findById or else throw. When Spring tries to return employee as JSON, it may fail if department is still a Hibernate proxy. Root cause. The root cause is usually this combination. JPA entity returned directly from controller, lazy loaded association exists. Hibernate creates proxy using ByteBuddy. JSON cannot serialize the proxy internals. Example concept. JPA entity plus lazy relation plus direct JSON response equals possible proxy serialization error. Most common fix. Use DTOs. Best practice. The best and cleanest solution is do not return JPA entities directly from REST APIs. Return DTOs instead. Example DTO public class employee DTO. Private long ID, private string name, private string department name. Public employee DTO, long ID, string name, string department name. This ID equals ID, this name equals name, this department name equals department name. Getters and setters. Service mapping. Public employee DTO, get employee long ID. Employee repository.findById or else throw. Return new employee DTO. Employee.getId, employee.getName, employee.getDepartment, not null, employee.getDepartment.getName, null. Example concept. Entity loaded means mapped to DTO, means clean JSON response. This avoids exposing Hibernate proxies completely. Why DTO is the best solution? DTOs solve multiple problems. Avoid Hibernate proxy serialization issues, prevent infinite recursion in relationships, keep API responses clean, protect internal entity structure, and improve API design. Example concept. DTO means no proxy internals, means safe JSON serialization. Fix 2. Ignore Hibernate proxy properties. You can tell JSON to ignore Hibernate-specific proxy fields. Example import com.factor JSON.annotation JSON ignore properties. Entity @JSON ignore properties Hibernate lazy initializer handler. Public class employee, ID, private, long ID. Private string name. At many-to-one, fetch equals fetch type lazy. Private department. Example concept. Ignore proxy helper fields means serialization may succeed. This is a common quick fix, but it is not as clean as DTOs. Fix 3. Force eager loading carefully. You can change lazy loading to eager loading. Example at many-to-one. Fetch equals fetch type eager. Private department. Example concept. Association loaded immediately means no lazy proxy problem. But this is not always recommended because it may load too much data. It can hurt performance. It can cause N+1 query issues. So use this carefully. Fix 4. Initialize lazy relations before serialization. You can force initialization before returning the entity. Example employee. Employee equals employee repository.findById.or else throw. Employee.getDepartment.getName. Force load, return employee. Example concept. Access lazy field early. Means Hibernate initializes object. Means Jackson sees real object. This may work, but it is often a workaround rather than a strong design. Fix 5. Use join fetch inquiry. A better way than switching everything to eager is to fetch needed associations in the query. Example, at query, select E from employee E, join fetch E department, where EID equals ID. Optional employee, find employee with department, at param ID, long ID. Example concept. Query loads needed relation fully means proxy issue avoided. This is more efficient than blindly using fetch type eager. Fix 6. Register Hibernate module for Jackson. Jackson has a Hibernate module that can help handle Hibernate proxies. Dependency. For modern Hibernate Jackson versions, use the matching Hibernate module dependency for your stack. Then, register it. Import com.faster/jackson databind.module. Import com.faster/jackson datatype.hibernate5. Hibernate 5 module. Import org.springframework.context.annotation.bean. Import org.springframework.context.annotation.configuration. Configuration, public class, Jackson config. At bean, public module, Hibernate module. Return new, Hibernate 5 module. Example concept. Hibernate module added means Jackson understands Hibernate proxies better. This can help, but DTOs are still the preferred architectural solution. Fix 7. Use at JSON ignore on problematic relations. If you do not need the relation in the response, ignore it. Example at many-to-one fetch equals fetch type lazy. At JSON ignore private department. Example concept. Ignore relation means Jackson skips field, means no proxy serialization error. This is useful when that relationship should not be exposed in the API response. Related problem, infinite recursion. Entities with bidirectional relationships often cause not only proxy issues, but also recursion issues. Example, department has list of employee has department. Then Jackson may keep serializing both endlessly. Typical annotations used there include at JSON managed reference, at JSON back reference, at JSON ignore. Example concept. Entity relationship graph means recursion and proxy issues often appear together. Real-world example. Entity at JSON ignore properties, Hibernate lazy initializer, handler, public class order, add private long-id. At many-to-one, fetch equals fetch type lazy, private customer, getters and setters. Controller at getMapping, orders/ID. Public order, get order at path variable long ID. Return order repository find by ID, or else throw. This may still be risky. Better approach public class, order DTO, private long ID, private string customer name. Public order DTO, long ID, string customer name. This.id equals ID, this.customer name equals customer name. / getters and setters. Example concept. Return DTO instead of entity means safer REST response, Why the error mentions ByteBuddyInterceptor. Hibernate uses ByteBuddy to create proxy classes dynamically. So, instead of a plain entity class, you may get a generated proxy containing org.hibernate.proxy.pojo.bytebuddy, ByteBuddyInterceptor. Jackson does not know how to serialize that internal Hibernate interceptor object. Example concept. Hibernate proxy implementation equals ByteBuddy generated helper object. That is why the error message looks strange and technical. Common mistakes. 1. Returning entities directly from controllers. Very common cause. 2. Using lazy relations without DTO mapping leads to proxy issues. 3. Making everything eager. This may hide the error, but create performance problems. 4. Ignoring API design. Exposing entities directly couples database model to API model. 5. Mixing serialization fixes with fetch problems. Serialization issue and fetch strategy issue are related, but not exactly the same. Best practices. Best practices include: use DTOs for API responses. Avoid returning JPA entities directly. Use fetch joins for required relations. Use @JSONIgnore or @JSONIgnore properties only when appropriate. Keep lazy loading for persistence design, not API design. Treat serialization as part of API design, not as an afterthought. Example concept. Good API design plus DTO mapping equals fewer Hibernate JSON problems. Advantages of understanding this error. Once you understand this error, you can fix REST serialization problems, faster design, cleaner APIs, avoid exposing Hibernate internals, handle lazy loading more safely, prevent related issues like infinite recursion. Example concept. Better JPA plus JSON understanding means more stable REST APIs challenges. This issue is confusing because the entity looks valid. The error mentions internal Hibernate classes. The real cause is often lazy loading plus direct entity serialization. Quick fixes may work temporarily, but hurt long-term design. Example concept. Simple API response means hidden ORM proxy complexity underneath. By learning this topic, you understand. Check. Why Hibernate creates proxy objects. Why Jackson fails to serialize ByteBuddyInterceptor. Why lazy loaded relationships often cause this error. Why DTOs are the best long-term solution. How @JSONIgnore properties, @JSONIgnore, fetch joins, and eager loading can help. Why API design and persistence design should be separated. Simple definition. No serializer found for class org.hibernate.proxy.pojo.bytebuddy.bytebuddyinterceptor. A JSON serialization error that happens when Jackson tries to serialize a Hibernate lazy loading proxy instead of a normal entity object. Final summary. The error, no serializer found for class org.hibernate.proxy.pojo.bytebuddy.bytebuddyinterceptor, usually happens because a Spring Boot REST API is returning a JPA entity that contains a Hibernate lazy loading proxy. Jackson tries to convert that proxy to JSON and fails. The best solution is use DTOs for API responses. Other possible fixes include @JSONIgnore properties, Hibernate lazy initializer, handler, @JSONIgnore, fetch joins initializing lazy fields before serialization, adding a Jackson Hibernate module. The key idea is that JPA entities and REST responses should not always be treated as the same thing. Once you separate them properly, this problem becomes much easier to avoid.